Hello everyone, I hope all of you are doing great. Today we are going to start crude oil processing in oil refinery. So the first step towards crude oil distillation, we have to create petroleum assay using different crudes. For example, in this case, we will use light crude oil, heavy crude oil and medium crude oil to create a blend, and we will have calculate the petroleum assay. So this is the part one. So in this tutorial you will mainly learn how to generate petroleum assay from light crude, medium crude and heavy crude, and to have a mixed crude for atmospheric distillation column. And also in the same lecture you will see how we can simulate preheat train for atmospheric distillation. So in the end of this series, this is the final simulation that you will have after 4 lectures. So this one is the first one. So today we are going to simulate the first part, crude oil preheat train, until here. In second part, that will be the next lecture, we will simulate the atmospheric crude distillation unit, and in third part we will perform simulation to have a debutanizer to stabilize the naphtha, and in fourth part we will perform the vacuum distillation of ATM column residue. So I hope this will help you, and it will give you the overall idea of oil refinery. So let's get started. So here I have the data, that is this one is for light crude assay data. So I will recommend you just take a screenshot here, so you will able to insert this data when I will perform calculation in HYSYS. Okay, so this one is the light crude assay data, this one is medium crude assay data. Here we have initial boiling point and final boiling point. This is the true boiling distillation curve, and these are the cumulative yield in weight percent for with respect to initial boiling point and with respect to mid boiling point. And these are the densities for each cut, also the sulfur weight percent for each cut. So these are independent. These are the first two values are for bulk properties for assay, but we have independent values for each cut, and we also have the light and weight percent in each type of crude. Okay, so this one is the medium crude, this one is the heavy crude. So we have these three crude. We will generate a petroleum assay by introducing all these three crude, and then we will make a blend that will be the mixed oil that we will take into the simulation for to perform atmospheric crude distillation. Okay, so this one is the problem statement. First we will create the petroleum assay and we'll export the crude oil into the flow sheet, and then we will have to insert these two preheater and one desalter and another one atmospheric crude heater, and then this oil, the hot crude, will be ready to introduce into the distillation column. Okay, so let's move to the Aspen HYSYS to start this. So we are in HYSYS. So the first step is we have to introduce components. Okay, so I am just going to insert the light ends, that is the until N-pentane. Okay, and also water. So let me check. So ethane to N-pentane. Okay, and next step we have to select a property package because it's pure hydrocarbon system. The Ping Robinson would be the best one. So just click on Ping Robinson. So this property is done. The next step, now we have to create petroleum assays. Okay, For that, just click on Oil Manager. Okay, and then click the Input Assay, then Add Assay. Okay, then we have here bulk properties. Yes, we will use bulk properties, and assay data type, true boiling point we have. Okay, and light ends, yes, we have input composition, and density curves, yes, we have, and they are independent. Okay, and the true boiling conditions are atmospheric one. So here first let's insert the distillation data. For that we have to change the assay basis from mole to mass, because data is given in weight percent. Okay, so you can see here. So these numbers, these are the temperature. Okay, so I will just copy these one. Okay, initial boiling point, and then here you just click edit assay, and here you can see there is only one number, but we have total 11 data points. So assay percent and assay temperature. So I also have this data in Excel file, so it will be easy for me to take data from here to copy paste. Okay, so I will take data from Excel. So initial boiling point for light crude. Okay, so here, so we have the temperature, and now the assay percent, assay weight percent, and that one is this one, cumulative yield. Okay, just copy and paste. Okay, after that just click OK. So it says table is ready. Similarly, just now click on density to define the density curves. So here the density is pound per cubic feet, that is also given. So just simply click on assay data, but here you can see the bases are midpoint bases. Okay, so just add the data points here, and come here. So the midpoint are this one. Okay, so Control C and Control V. Similarly for density, and here we have the density from here to here. Just Control C and Control V. Okay, then press OK. So the density is okay, and now go to the bulk properties, and in bulk we have a standard density. Okay, that one is this one. I just increase it, maybe you will easily see. So this one 53.27. So 53.27, let's press enter. So the bulk property we have only this one, and now just define the light ends. Click on the light ends, and it says light end basis is liquid volume percent, but we have mass percent. Okay, so it's weight percent. So we will again copy this data, Control C. So it starts from ethane, Control V. Okay, so now we have defined bulk properties, light ends, distillation data, and density data. One thing is left, That one is the sulfur content or the sulfur weight percent. So how we can define the sulfur weight percent, because here we do not have option. For that, what we will do, before calculating this assay, we will go to the user properties, okay, and we will add a user property here, okay, and here it says mole fraction, and we will change it into the mass fraction, and the lower limit should be 0, the upper limit should be 100, and here the property component in master component list property value, here I'm just going to insert 0 0 0 0 0 0 0, because we will insert sulfur values later. So at this moment I'm just inserting 0 0 0, okay, and after that, when you select and click it, you just again go to the user properties and maybe change its name for future use. I will say it sulfur 1, okay, and now again go to the assay, okay. So when you are here, you just go in the top ribbon and click user curves, okay, and here you can see sulfur 1 is already there. You just add sulfur 1 here, okay, and the table type should be independent, and the bulk value, yes, we have a bulk value for sulfur. That one is 1.77, 1.77, okay, and the all other things will remain the same. And now we have to edit assay here, okay. So the assay percent, so this one is also on the base of midpoint values, okay. So I will copy this one, midpoints, Control C, and I will paste it here. So it's 97.5 is the last value, yes. And now go to the sulfur weight percent, okay, copy this one and paste here, click OK. So here yes, everything is fine. So now we are ready to calculate our first assay, okay, for light crude. For that, just we have to click on calculate. So you can see assay was calculated, it's turned into green. Similarly, I will insert assay 2 and assay 3, that is for medium crude oil and the heavy crude oil. So that I am not going to explain by word. After that I will continue. So from here I will speed up the video. Well, now we have defined all three petroleum assays: light crude, medium crude, and heavy crude. And now it's time we are going to make a mixture or blend of these three. Okay, so for that, you just have to come here and click on output blend. Okay, and then click add. Okay, so here we have all these three oils. Okay, so I will add all of them. So light crude, heavy crude, and medium crude. So the flow unit should be liquid volume, and for flow rate we should take equal quantity for each to make the blend. So here I am just taking 33,000 barrel per day. Okay, 33,000 barrel per day, and similarly here 33,000 barrel per day. Okay, so now you can see it says blend was calculated. Okay, so we will just name it mix oil. Okay, so we have created a blend of these three oils. The next step is we will export this oil into the main flow sheet. For that, we just have to come here, output blend, and from here we can see the our oil is here, mix oil, and then you should click on oil manager. Then this new window will appear, and we want to install this mix oil. So for that we just have to click on install oil, and here this one is the mix, and I want to change its name crude oil for the flow sheet. Okay, and then just click on install. Okay, so this crude oil is already has been shifted into the simulation environment. So you can see that with all the properties and characteristic, we have created a petroleum assay by blending light crude, heavy crude, and medium crude. Okay, so the next step is we are going to create a preheat train. Okay, so for that, here we have the flow sheet. We need 3 heater and 1 mixer. Okay, so just take 1 heater, second heater, and the third heater. Okay, and 1 mixer. We need 1 mixer, and the icon of the third one is different because it's kind of a furnace, so we will use this one. Okay, so just click on crude oil as an inlet. Outlet is, I will say, warm oil, and Q1 is the energy that it is taking. Close this one, and then here this one is the salter water. This one is the salter, and the warm oil, and this one is wet warm oil. Okay, close this one. So here wet warm oil, and energy is Q2. here I will say oil, close this one. The inlet is oil, outlet is hot crude oil for distillation column, and the energy is Q3. Okay, so now we just have to adjust a little bit. So let's specify the parameters that have been given. So the temperature of crude oil, it is given, that is 100 degree Fahrenheit, 300 psig pressure, and 101,000 barrel per day. Okay, so the temperature is 100, pressure is 300 psig. So I have to change it psig, and the standard ideal liquid flow rate, it is 101,000 barrel per day. Okay, and next step is, if we see the composition, that is okay. So we just have to active. So the crude stream is specify, and then the preheater one, outlet temperature and pressure is given 260 and 294. So here, this one, the temperature is 260 and pressure is 294 psig. Okay, so the first preheater is simulated. So go to the for desalter outlet, 260, 294 and 500 barrel per day of water. So for water, I will put it here 500. Okay, and 194 psig, and the composition is only water. Press OK, and here the temperature 264. So the desalter is also simulated. So the second preheater 450 and 260 psig, 260 psig, 260 and 450 temperature. So this one is also done. So the last one, the hot crude, the pressure is 25 psig to enter into distillation column, and temperature is 634 degree Fahrenheit. Okay, so today we create petroleum assay using 3 different crude oil, and also we simulate the crude oil preheat train, and in next tutorial we will simulate atmospheric crude distillation unit to separate this crude oil into different fractions. So I hope you understand it and like it, the tutorial. Please don't forget to subscribe and like the video and channel. Thank you so much for watching. Until next video, bye bye.